I'm gonna put the link on.
C'est pas viable. On fait une grosse all these projects autour de ce qu'on oui. Sorry, all but one of them. Moi, oui. For me, I was more a post box.
Oh yeah, we can show you. But everyone sends you one of the other Yes, can we start our
It's only to connect it and that's it.
I'm gonna go just hey, my friend, you're here. Next month. I'll have a break for talk. I need to start. This is unique. I'd rather keep
Fine, I just need to check the
Sure. I was going to say when
I think everybody's ready, right? So the presenters are here, so I think we can start. So again, welcome to the second Kubernetes and Cloud Native Meetup in Montreal. So we usually do it every quarter, but this time, because there was so many presenters and so many people who want to present, and I guess there's still interest from your side that you want to come and learn more stuff. So we decided to do 2 meetups in the Q1. And if you guys gonna like it, we will try to do it more often as well. So today we happy to announce one of our sponsors that helped us to organize this meetup. So Microsoft, as we said the last meetup, that became one of our main sponsors, and this time they actually helped to organize all this event, sponsored the food, and we also get $300 Azure access. So if you guys have questions, we're gonna distribute a lot of them. We have like 60 of the cards to access the Azure cloud. So if you participate, hopefully you'll get one of the accesses. So yeah, very excited that Microsoft is really love Kubernetes. They acquired Deis team, and they're doing a lot of work in upstream side of Kubernetes, working on Brigade, on Helm. There's other small projects, but also in Azure. Right now they announced K8s. So if you guys want to try it, you'll get the $300, and you can try GPUs and K8s and whatever you want to do in Azure Cloud. Also today we really thanks for Nuance Communication who provided this nice location. So hopefully it's going to be, if you guys like it here, let us know. We can do more meetups here. It's a nice location. Maybe a little bit hard in terms of organizing first time, but we really appreciate seeing ourselves. Yeah, lessons learned. We're going to be better next time. So we want to also thank JFrog today, but unfortunately couldn't make it. So the guy who's supposed to present on Helm, he's stuck in Chicago airport because of the snow, and unfortunately he's not going to make it, but we're going to try to invite him in May next time. And finally, Mesos, today they're going to have a talk. They're not our sponsors yet, maybe at some point. But yeah, definitely, I know in Montreal there's a lot of big data companies and people like big data, so I remember when we started the meetup about Kubernetes, there was a lot of people who was using Mesos and they want to run Kubernetes. So finally, Mesos guys did something very easy, so you can do one quick installation of Kubernetes on Mesos, and they're going to do demo and present about this. All right, so let's keep moving. As usual, the Slack channel. So people on the Slack right now, we're providing a link for them in the live streaming, so they can participate in the meetup. But yeah, if you don't have the access yet, take a picture. It's a Slack channel where you can get all the slides from all the meetups. We're running the meetups in 5 cities right now, and we also share a lot of information. And there's some companies that get a free enterprise support, just asking questions all day, how to fix this problem, and you can join, either answer the questions or ask the questions. Yeah, and also like really want that you get involved. So please submit the talks. So we always try to bring new presenters from different cities, different companies, but we really want that community to also participate, share their experience, their success with Kubernetes, or maybe problems, or anything that we can learn from the community is really appreciated. So please submit the talks and help us to organize. We will really appreciate it. Yeah, and as we said, Meetup is organizing a series of the Kubernetes workshops. Usually the talks we have at the meetups are very advanced topics, and people who are just starting with Kubernetes, they have a lot of questions. So we put a series of the workshops around Kubernetes, and also Kubernetes in different cloud providers like Amazon, Google Cloud, and Azure. This is all of our partners of Meetup. So together in partnership, we build all of those workshops. So if you're interested, please let us know or take the picture. Yeah, so the next workshop is going to be in Montreal and Toronto. This is the date. I don't know how I'm supposed to call myself to be in two cities at the same time, but hopefully somebody is going to help me to deliver those workshops. Yeah, so this is the barcode if you have any questions. And finally, CloudOps is hiring. So if you guys are interested to work and work with Kubernetes, and this is very open source oriented company, a lot of technologists, please join us. So we right now looking for the container solution architects. So we just hired Adrian and this guy Mike from Toronto. But like, if you guys are interested, please let us know. Also, I just did a workshop in UCAM. Yeah, and the gentlemen over there, they also hiring for Kubernetes engineers. And also, if you guys looking to work with Kubernetes, we have in the Slack channel, we have a Kubernetes careers. So if you want to post the jobs about Kubernetes, or you're looking jobs to work with Kubernetes, just you can go and check in the Slack channel. There's always like, especially companies around AI, they're using a lot of Kubernetes these days. With Google Cloud, it's like they hire crazy, right? So all the time, people asking, do you guys have anybody who wants to be like the DevOps engineer on Kubernetes, CI/CD, and stuff like that? Yeah. So today agenda, quick update from the ambassador team. We're gonna talk about horizontal port autoscaling. Do you guys know what is that? Who knows horizontal port autoscaling? Yeah. So hopefully, for people who doesn't know, you're gonna learn as well. But this is really the horizontal port autoscaling. It's a feature of Kubernetes. When your website is super popular, it's gonna automatically scale and serve all of your users. So the problem we have with horizontal port autoscaling, it's only working per CPU by default using Hipster, and everybody's dreaming to use custom metrics from their application like QPS, or maybe number of sessions, or any software that you're running. You wanna use your custom metrics for the software. So Luis Tabon hopefully gonna explain how this works. Yeah. So yeah, he's gonna talk about Prometheus. He's gonna talk about Kubernetes. So hopefully the demo is gonna work as well, right? I hope so. And also Sylvain, who helped us to organize, he will have a very quick talk about how Nuance handled the Spectrum Meltdown upgrade in Azure. So hopefully they had a good experience, because our experience was not as smooth. But the Kubernetes side, we actually followed all of those best practices that he suggested. But our SQL database was not running in different failure domains, so we have an outage actually. So he's actually going to talk about those things and how to solve similar problems that you can have during the patching and stuff like that. And finally, we have a guest from DCOS, Mark. So not Mark dead. Sorry, okay, my bad. So yeah, that is, they have a lot of swag here, stickers, but also they will have a draw for the t-shirts, or just if you ask questions, they're going to give you t-shirts. So stay tuned. So this is going to be our last talk, and as I said, Helm guy, Baruch, who presented in all cities in Canada, but he has like a bad luck with Montreal for some reason. Actually, his first slide is about weather in Canada. Yeah. Okay, so I have a quick update. There's nothing major happened since last time. As we talked about 1.9. So again, this setup is about Kubernetes first of all, but also we have so many different CNCF projects. And as we spoke last time, we have incubation and the projects that initiated CNCF, but we never had any graded project. So there's like 3 levels of projects. So now Kubernetes is the first project in CNCF that is became graduated project because of the huge success. There's a lot of people some companies using in production, big companies, small companies. There's a huge community, and pretty much it was very clear that Kubernetes is going to be the first one who's going to graduate, and this has finally happened. So officially, Kubernetes is the first graduated project. So if you go to the there's this landscape CNCF.io page. Right now, they just created, so you can see the different projects that are still in incubation. And we have 2 projects that are still in the initiation state, which is Linkerd and Rook. And there's a lot of interesting information. If you guys are interested, you can scroll down. This is not only related to CNCF, but all of the cloud native projects that are very popular. They updated the website, and you can pretty much do different searches. Very interactive, interesting website. So obviously, some people like to read books. I'm one of them, so I read all the books around Kubernetes, cloud native. So a couple of my friends, Sebastian Goscan and Michael Hesselbaum, they are also ambassadors like me. So they wrote book Kubernetes Cookbook. It's available. You can buy it on Amazon. And I just, very waiting when this book is going to be released. Prometheus up and running. So this is one of the guys who works with Prometheus a lot. He's an Irish guy. He wrote starting to write a book. It's still early release, but you can, if you're using Safari online, you can actually have an access to it and read it.
Is that Brian Brazil? Yeah,
Brian Brazil. Yeah. So his action is very hard if you watch his videos, but like the book you can read no problem. It's Irish accent, so yeah, I'm looking forward when this book is going to be fully published because I found that Prometheus is a very popular project, but the documentation is so hard, the information is so scarce, and hopefully today we're going to learn a little bit more of Prometheus, but like really everybody talk about Prometheus, but like it's very hard to it's easy to install right now already, but still like it's still a very difficult barrier to enter the project. So some of the events, there was already actually events I was hoping to go, but unfortunately my company didn't let me go to those events. But there's a big event that is coming that I'm going to KubeCon. I don't know if anybody here goes to KubeCon. That's 2 days. Okay, so we'll have a chance to meet there. So, but we just had a big event, Helm Summit. Rodrigue, are you here? No. So, Helm Summit, you guys know what is Helm? Helm is package manager for Kubernetes. There is a lot of hate propaganda about this project. Most of the people, who is using it, like they kind of say, oh, it's not secure, or there's so many problems. And actually, that's one of the reasons that they decided, okay, so let's bring all of the communities together and have a Helm Summit, which was like a few weeks ago. And there was very interesting talks from the companies who are using Helm, and I was very surprised to see how seriously companies using this project. So I just you can go find the videos if you're interested. But I really recommend Helm Journey from Ubisoft. This is one of our guys, Rodrigue Poitier. I was very impressed how Ubisoft is using Helm very seriously, and they do a lot of contribution to the Helm project. I'm very excited about that. So maybe next time they can present here. If you want to, once you create multiple charts, you want to store those charts somewhere. And this is something you should have object storage with a website. And it's usually, you can set up yourself, but there's a problem with concurrency when there's a lot of people contributing and uploading it. So there's it's kind of a painful experience to store Helm charts. So one of the ways to store Helm charts is the guy from the JFrog. He's supposed to talk about JFrog has a feature now that supports Helm chart repositories. So I'm not going to repeat his talk. He's going to come and talk about his talk. But there's actually open source version. It's called Chart Museum. There's a guy who wrote a very nice website that you can actually deploy easily, and you can store your charts, and you can contribute and use it for the CI/CD purposes. It's very well designed, and there's so many people using it. It's like the most popular GitHub right now related to the Helm. Helm at Reddit also, like Reddit is the company. They also really serious with Helm, so they're using it for the CI/CD, and they had a good talk about how they're using it for CI/CD. And my favorite friend, Australian guy, Lachlan Evanson, he's also one of the ambassadors. He had a really nice talk about securing Helm. It's also available on YouTube. So if you want to learn how to secure Helm, and you probably know most of the problems if you kind of using the Helm, but he kind of tried to summarize and put a plan forward together how they're going to solve those problems as a community. And the second day was pretty much, I don't know, I wasn't there, so I don't know, I was hoping Rodriguez here is going to talk about it. Probably they get drunk again, because as you know, you guys know how the Helm was created, right? So the guys from Days, they had a hackathon, they get drunk, and then they wrote Helm. And then, Google kind of joined the effort, and they put it together, and this is what we know Helm 2. And what we're using right now, Helm 2 is a very popular project. There's so many charts right now stable, and in Incubator, you can use it for free, like install Postgres, Jenkins, whatever. The community is supporting it, and people using it, like everybody loves them, right? But this is Helm 2, and pretty much the decision has been made that we, Helm 2 has been created when Kubernetes was 1.3, and right now Kubernetes is 1.9. There was so many changes, like we have CRDs, we have operators, and like the Helm design was, from the beginning, was wrong because you need to install Tiller instead of the namespace. So they basically get together, all the companies who's using it, and the core contributors, developers, they decided to start Helm 3. So right now, Helm 2.9 is going to be the last release, and then the next one is going to be Helm 3. So people slowly going to be migrating to Helm 3, and it's going to be in development, and hopefully they will solve all of this limitation with the security. Hopefully, some people propose not install Tiller anymore on Kubernetes side, use local Tiller. So there's all of the feedback has been kind of collected, and we're expecting that the Helm 3 is going to solve all these problems, and they will slowly move all of the charts to the Helm 3. So we're going to be waiting during the year. I think in the mid-year, it's already going to be some release, and you can start using it and provide first feedback. Any questions for Helm 3? No? So GrafanaCon, why this is related to CNCF? Anybody has an idea? Prometheus. Yes, Prometheus. So Prometheus, as you know, is the best monitoring system these days for Kubernetes, because it's having all of those features with the tagging, dynamically finding all of the workloads that you put in there. So Grafana community, or pretty much Grafana project, is the main dashboard for Prometheus, because Prometheus itself doesn't have a good dashboard, and they never put this task for themselves. They said, there's a good dashboards out there, we're not going to create our own dashboard. So Grafana, last year, they announced huge support for Prometheus, so you can do pretty much querying and write queries in the Grafana and create nice charts for the Prometheus. So this year, they basically said they're going to continue to improve. So they just released Grafana 5.0, which is supporting teams and permissions, so you can create different dashboards for different team members in your company. There was a few other updates that I need to recall exactly what was there, but this time it was nothing major, but they still kind of improving the UI experience, UX experience, how you can design those dashboards. But from the demo, they showed dashboards are really you can put easily any graphs now, drag and drop. It's become so much easier right now, Grafana. And yeah, Grafana guys also working on another monitoring system called Graphite. It's very old, very popular in the past, but has some limitation with Kubernetes. So they actually recreated Graphite from the scratch, and they wrote a new version. Well, actually, they graded Graphite to be 1.0, and they wrote 1.1 version that also works with Kubernetes. It's supposed to work nicely with Kubernetes. And they also added if you don't have a good storage for your Prometheus cluster, you can actually use Graphite as a storage because their storage is more evolved than Kubernetes. So it was pretty much very interesting event. I really want to go, but unfortunately I was busy. I couldn't make it. But like that was a kind of recap from the Grafana Conf. And then the next event is going to be in Copenhagen. This is KubeCon, and it's going to be the biggest KubeCon ever, I guess. I think there was a lot of, it's going to be again a lot of talks about Istio, but like I'm very excited. It's going to be a very good event. So if you can make it, please talk to the managers and try to make it. It's going to be a good event. Yeah, and then the next one is Shanghai, and I guess nobody goes to Shanghai because it's more like for the Asian region, but like pretty much at the same time we're going to have KubeCon in Seattle, so that one I think a lot of people are going. Okay, so what's new in Kubernetes 1.10? I don't know yet, but actually the code freeze happened, so you cannot, if you have any features you want to put in 1.10, it's too late. It's already code freeze. So they're going to be releasing very soon. So 21st March is the date when they're going to release 1.10. Hopefully next meetup we can talk about 1.10. But for now, let's talk about the talks that we have. So yeah, the Slack, we have stickers, we have t-shirts. If you have any questions, you can start now. We can start giving you the stickers. Any questions, guys? Questions?
Not yet. Some the presentations will come.
Okay, then I will probably slowly move to the first presenter, Luis Tobon. He's from Nuance Communications. He works here, he eats here, he sleeps here, and he even presents here. So we'll talk about HPA. Thank you very much, and keep your questions.
Okay, my name is Luis Tomon. I work here. I don't sleep here. I eat here. And it's the first time I present. I'm going to talk to you about horizontal follow to scaler. And my first question is, who knows what HPA is?
Should I give all the stickers?
If they define it.
Okay, I'm going to start by what is HPA, but we are going to focus this talk about custom metrics. There are three ways of HPA. I'm going to explain the three kind of flavors of HPA that we have, but I'm going to get more in details with the custom metrics. What I'm going to present you is basically the result of our own experience with HPA. So we have been playing with this for the last few weeks, month. And so I'm going to basically share our experience on that. Now, what is HPA? Right here. Basically, it's kind of a feature that allows Kubernetes to scale up and down your pods based on metrics. So if you have a lot of traffic, you're going to have more pods. If you have less traffic, you have less pods. It's pretty useful when you run in a cloud. In our case, if you have your own data center, you already have the machines, they are there, and you are using it. But if you're in a cloud, it will be very good if you can actually scale your pods and then reduce the pods if you don't have much traffic, and then eventually turn off the machines. And that brings me to the other thing, which is auto-scaling is different of cluster auto-scaling. So it's not necessarily when you scale up pods and reduce pods, you are not actually killing machines, you are only killing pods. Just to clarify this stuff. It's done by the controller manager. So basically, the controller manager is running the Kubernetes master. So you don't actually have to write a specific logic to scale up and down. What you have to write if you are using custom metrics is whoever is providing the metrics. but the scaling process is done by for you by Kubernetes. Something important here is that it cannot be done for, I mean, it can only be done for components that can be scaled, so you cannot do it for a daemon set, for example. And as far as I know, it only works if you have rolling updates and HPA. The only component that can work in both for both the scenarios is the deployment object. So you cannot do it with application controller, for example. And basically how it works, so it's pretty simple. Every X seconds, by default it's 30 seconds, is going to HPA, Kubernetes, the horizontal scalar controller manager is going to ask for a specific metric. Based on that metric, it's going to calculate the number of pods that he should have, and then it scales the option. That's pretty simple. Now this is kind of a diagram of how this works. What we have here, what is in kind of the dark blue is what you already have, and the light blue is what you need to create. So you have a scalable object, whatever, a deployment object, for example, that it has some pods. Then you have your Kubernetes master, and you may need to have some metric server. But let me talk to you about this later. Then you define a Kubernetes HPA object. I have an example of this. I will show you how this works. And this object is going to point to two things. It's going to point to whatever you want to scale, so a replication controller, a deployment object, whatever. And it's going to define a metric. So in the metric, basically, it's composed of two things. It's the metric that you want to use as a reference. I'm talking specifically for custom metric. And who is providing this metric. I'm getting in more detail later. And finally, you need to provide what is your expected value for this metric. So if you have a metric, in our case is utilization, you want to keep utilization at, let's say, 80%. And if it goes to more than 80%, it's going to bring more pods. If it goes below, it's going to be less. It's going to start deleting pods. And that's pretty much it. Then here you have the Kubernetes master. In the Kubernetes master, you have the controller manager, and one of the controllers is the HPA controller that is already there. And then you have the Kubernetes API. Now, talking specifically for controller manager, for custom metrics, there is something important you need to know. Actually, two things. First of all, there are kind of two generations of HPA. One was based on Hipster, and the new one that is kind of whatever you want, but most likely it's going to be Prometheus-based solution. Is what we did. And you need to have a Prometheus server. I didn't put it here, and I did it in Propose, because basically what you need to have is the following. You need to have a custom metric server. This custom metric server basically is it's enhancing the Kubernetes API. Because what is happening is that HPA is going to send a request to the Kubernetes API asking for something, and the Kubernetes API is going to forward the request to your custom metric server. So it's here where you are going to actually have whatever you want to do to provide a specific metric you have. In the real life, what you have is kind of this component in the real life is should talk to a kind of metric server, storage, whatever. In our case, it's Prometheus, but could be whatever you want. You could actually can store the metrics there by yourself. It's up to you. And basically, this is an example of how we use Prometheus operator for that. Okay.
I want to break down a question here.
Yeah.
Is there a default metric that is prescribed to optimize performance? Because there's no guarantee that the metrics that are considered, unless of course you have a multi-metric input.
Yeah.
Is there a standard? Is there an industry standard already to optimize performance? Coming up with a metric at random is certainly not really prescribed enough of costs.
I'm going to answer your question kind of in 3 slides, but 2-3 slides. But basically, there are 3 kind of metrics you can use. the first metric is it's resource metric, I believe is the name, and it's CPU or memory. I don't know if there is something else.
Resource utilization.
Resource utilization, and it's quite straightforward to use. And actually, that is the one who used this blue box that is basically a metric server API, and that is the one that stores all the metrics from your box. There is the second type of metric, which is pod-specific metric. I don't have any detail of it. It's metric that is provided by every single pod. And then the third one, which is custom metric. And to answer specifically your question, is every use case is different. We have a very specific use case that I'm going to share you, and that is perfect for us. So the custom metric, we have a metric that we have some specific component that knows what is the utilization, and actually he will even know how many pods he needs to attend the traffic. And with that component, is providing a specific metric that is calls on that. Yeah.
So if you take vanilla Kubernetes, is it all of those components will be there, or you have to enable them?
You're not going to get one of those. Yeah, basically whatever is. You have a vanilla Kubernetes, you have whatever is in dark blue, let's say. You will need to create this object, which is just a Kubernetes manifest, and then you need to deploy this guy, and whatever this guy needs. So this guy usually will need a Prometheus server, you need to deploy Prometheus. And if you have, for this kind of regular resource metric, you need this other guy.
This is kind of in-memory database?
Yeah. Yeah. This metric server API is this is the metric server API that is used for the resource metric. So it shouldn't be there if you are using custom metrics. And then you need to apply a few flags to the Kubernetes server. I'm going to show you what those flags are. And actually, those are the flags. So basically, if you want to enable HPA Kubernetes, it's not enabled by default. In 1.7, you need to enable more things than in 1.9. But basically, you need to configure the registration ledger. You need to enable the product scaler, and basically, you need to activate the custom API because by default it's not activated. And then you can tune it. What you can do with HPA. Now I have a small parenthesis to tell. We have some pain because what we wanted to do in terms of HPA was not exactly what HPA was offering to us. So we're kind of suffering a little bit, but what you can do is the following. You can change how often it's going to sync the metrics to perform the auto-scaling. There is a tolerance, which means if with the real lab, your metric is going to go like that. But you don't want to scale with a slide with a very small movement in your metric. So the tolerance tells how much the metric needs to change in order to scale more or to start out the scaling process. And the last two are actually very important for our own experience. They are very, very, very important. The last two means is if you do a scale up, how much time he needs to wait before performing the next scale. If he's doing a scale down, the same thing. If you should try to have this kind of alignment with the startup and the kind of killing time that takes for your process or your pod to take. If it's too short, it's going to go everywhere because it's going to scaling up, scaling down, and so forth. We actually have a ticket, an issue open in Kubernetes, hoping that they are going to fix it for 110, crossing fingers. I don't think it's going to happen, but it's something to relate to this, and I'm going to get there later. Now, part of the answer for you.
I'll have another question once again.
So this is a typical manifest file for a horizontal cloud scaler. I put in Repos the three metrics, so you can actually have multiple metrics in the same HPA. The way how this works is that it's going to calculate how many replicas he will need for every single of those metrics, and it's going to scale based on the more conservative one. So the one that gives you more pods is the one that is going to use. So it's kind of being conservative. So what you have there, you have so it's a horizontal plot scaler. This is the kind, and then you say what do you want to scale. So you have, in my case, it's a deployment object. You give your name here. Those two are very useful. What is the minimum number of replicas that is always need to keep? You need to have at least certain number. And what is the maximum? So you don't actually want to scale as Helm. You want to cap it at one point. And then there are three types of metrics. As I told you before, there are three types. One is resource. And for resource, there is CPU, memory, and something else. And the target metric. The second is for your pod. So it's a metric that is provided by the pod itself. And exactly the same. It works exactly the same. And the last one is object. Object is whatever. Object is whatever metric you want to have. You provide the name of the metric, and then you provide the target. So the target is who is providing these metrics. To be honest with you, at the beginning, I didn't understand why we have this. So I just have a metric name. Why I need to provide a target? What this target means. After playing with that, I understood that the same metric can be provided by multiple objects or by multiple resources. So if you have actually a multiple namespaces or multiple services, it's very likely that you are going to have the same metric in different places. So it's this way how you kind of target to a specific provider, let's say for this metric. And you are saying which a kind, let's say a service, and the name of the service, and then the target value. The target value is whatever you want.
So now my question is, in an ideal situation where the deployed services are constantly mutating, constantly changing, one would really have to switch between these different metrics, and even within the resource metric, one would have to weigh the resources differently. However, if one does that, I'm thinking in terms of artificial intelligence, using artificial intelligence to develop an algorithm to move between these, you actually risk driving instabilities in the system. Because by moving from one metric to the other, you cause overshoots and undershoots. Is there a way, a tested practice, which you combat that? Has that been tested or experimented with? And
maybe you can tell us your way using this.
So I will tell you our use case. Actually, the last slides are our use case. We have a specific server. That server takes a lot of time to start. That server takes only one Repos at the time, don't ask me why. And basically, there is another server that knows how many of the others are running, how many are busy, and how many are available, and how many requests you are getting, and kind of allow you to predict this. So based on that, we have a metric that we call utilization, and that utilization is basically how much of your resources are being used. Here is not important the memory, it's not important the CPU. The only thing that is important is busy or available. That's it. And we kind of have some simulations done by our architects that says what is expected, how the traffic is going to behave, looks like. So this allows us to keep, and we are using something that is called airlines. Have you ever heard about this?
Yes,
airlines.
Yes.
So we are using airlines to calculate the specific metric. It's a bit complicated, but it's basically that way that we are using. But a simple way to scale is say, like in scale used by CPU. I don't know.
Why did you choose Erlang's a programming language for this?
It's Erlang's. I'm starting to get to my not comfort zone.
Maybe Ericsson pushed it on you.
It's Erlang. I believe it's a theory or it's a mathematical approach for queues. It's not a language. It's not a language.
Erlang?
Erlang.
E-R-E-L-N-G?
Yeah.
Erlang language.
It's also a language, but in this case, it's not a language. It's actually a mathematical approach to manage queues and magic around.
Sorry, I have a question.
Yeah.
In this simple example that you have,
in this simple example that you have, so the HPA will trigger when one of the three metrics is above average, or all three of them, or
it's going.
All of them must be.
So he just showed one of the types available, but in their case they only use the third one.
Okay. We are only using one, but this is allowing to have all three in the same HPA. Yeah. And what it actually does is Do you remember this flag that I showed you? The first one, security. So every 30 seconds is going to recalculate the number of replicas for all three, and it's going to scale based on the most conservative one. That's basically the way of the three methods works. And this is the equation. It is one of my nightmares, by the way. Basically, what it has, what you see there, it gets the current number of replicas that you have for your resource. It gets the current value for your metric. It divides by the expected value, and then it comes out with a new number of replicas, and it's going to scale with that number of replicas. And something important to clarify here is what means current replica count, because there is a pod can be starting, can be dying, can be on schedule, it's in different states. So for Kubernetes today, current replica counts means all the pods that are ready, but also all the pods that are running and not ready. So you know that a pod can be in running, starting, and they are including those pods there. In our use case, our server takes like between 10 and 20 minutes to start. Because of NBN, until it actually starts, it's able to receive traffic. So because when they are in that state, it's being counted as current replica count, it's being over scheduling a lot. And so what we did is we kind of had to hack the Prometheus adapter server that I'm going to explain what this means. And we have, and this is the reason because we have the issue open in Kubernetes. Any question here?
I have a question.
Yeah.
So suppose you have are deploying a SIP server. Suppose you are deploying a SIP server and you have sessions for 3 minutes, for example, and your Kubernetes decides to downscale. It will just kill your servers, or?
It's yes, but Kubernetes has a very clear algorithm of how they scale down. When they scale down, they actually have a slide and I remove it. And they start by the ones that are not scheduled, the ones that are in unknown states, the ones that are initiating, the ones that are dying, and take the order. And then from the ones that are running, it starts killing the ones that are younger. Yeah, and then it keeps the oldest one as much as possible. And there is no way, as far as I know, to change this behavior. And we would like to do it because we have a use case for the opposite way.
Yeah. Right. I just want to say, ideally, everything should be stateless. Yeah. You have your session activity. This is your special use case.
Ah, yes. In theory, you should have a stateless server. That's if one pod dies, the other should be able to take the request. That's ideal world. Yeah, it's easier to say than actually to do it.
Exactly.
Yeah, and basically, do you remember that I said that this is what you want to that you have to implement? So the custom metric API, if you want to have your custom metric API, you need to vendor this repo and implement this interface that has 4 methods. Yep. This one?
The diagram.
For which Kubernetes cluster configuration I enjoy, like I have, let's say, cluster, 2 master nodes, or in this custom metrics API server.
Yeah, this guy basically is the Kubernetes master, but you have multiple master, it's going to be the same. So basically what happens is that you have the Kubernetes API, Kubernetes API that is in your master. You also have your controller manager that is also in your master. There is nothing to do here other than adding the properties that I just mentioned. And what you need to add is this object, of course, and you need to have your custom metric server. That's pretty much it.
And he's explaining.
And I will tell you how you get there.
So it doesn't depend on Kubernetes configuration.
The only configuration is the one that I just showed. Those 3 configurations. You just need to enable this, and you're ready to go.
Just to restate this question.
Yeah, actually, I just want to say we're going to share the slides in the Slack channel, so don't worry. We'll get the others.
So just to restate the question, so which element is referring to the custom metric? If you go back, Is that global to the Kubernetes cluster?
This one,
Is it specific for HPA? You have two HPA.
no. Here you have one server or service that is the one that is registered into Kubernetes matter. So let's say it's one. But when I say one, it's actually a service. You can have multiple pods serving this service. And what is here, in our use case, I'm going to show an enhanced version of this slide, where I actually give you details what this custom metric API looks like. Because you don't use a service. Use a service, and you have a metric storage behind the scenes, and more things. So I'm getting there. I will get there.
So the relation is 1 to 1.
From Kubernetes to, I will say yes. From Kubernetes master, Kubernetes cluster to server is one of them. I need to go fast, I believe. This one? Okay. So our use case, I already told you, it's a very expensive server, consumes a lot of RAM. I'm telling you, a lot of RAM. We need a lot of instances when there are a lot of traffic, and we would like not to have many when there is no traffic. And each pod takes up to 30 minutes to start, which is a lot. So this is kind of a very, very, very important thing when we implemented HPA. We are running a cloud, and the reason because this cloud is important is because when we were running our own private data center, we had the machines. The machines are there. We could have the pods running all the time, and we really pay the machines. But now that it's in a cloud, it's very good for us being able to scale down, so we can reduce the cost of the let's say the bill for those servers. And the other thing that is important is that there is another server, and that's why custom metrics is the solution for us. There is another server that is the one who knows how many replicas of the first one I need to have. So it's one server providing the metric and the other one that is being scaled. That's why custom metric gets important.
I've been struggling to understand how you can save money by scaling down just the number of pods.
Because when you scale down the number of pods, then you can scale down the number of machines.
Okay, but that doesn't happen automatically.
No, you need to do it. But you cannot scale the number. You cannot scale the machines if you don't scale the pods.
Right. Actually, I didn't see the missing piece.
Yeah, but that's the link. Is clear? Yeah. And that's pretty much what the traffic looks like. So it's as you can expect. There is peak hours where it's a lot of traffic, and we need to have a lot of instances at those times, and valid time when you want to scale down the pods. So now our solution. So our solution, the metric we have is utilization. So now I'll give you a little bit more details. So there is one server that knows about the metrics. So this server is the one who knows how many pods of the one that you want to scale are being used. How long have they been used, and how many total they are, how many are being used, and how many are available. And we are applying some airlines. Don't ask me what exactly airline is, but it's basically a mathematical approach to say how many instances you need to have in order to don't have people waiting in the queue. Very good. Then we have a custom metric server. So what I wanted to say is in the previous slide when I said a custom metric API server is not actually a server, it's actually multiple things. And we are using Prometheus for that. It's basically a metric storage. So we are putting all the components that generate the metrics, put all the metrics to this server, to this storage. And then there is a custom metric adapter that is actually there. It's open source. That it just plugs to the Prometheus and it provides the metrics to Kubernetes. It's all for free for you. By the way, the guy who created this Prometheus adapter, this direct X-Man, is the same one that is leading the project of HPA. So they kind of flow very well. And this is the enhanced version you were asking me before of the slide. Why I didn't put this in the first slide, because this doesn't need to be exactly what you're going to have. This is what we did, but you don't need to have exactly the same. So this Prometheus server can be a Graphite server or can be any database you want for metric. And this Prometheus metric adapter, it's an open source project. We had to fork it, and the reason is explained in the issue that is in this slide. And so what we did, we took the official one, that one, we did a fork, and then what we did is we apply a hack. It's a kind of ugly hack, but it works. And it works. And basically, what it does is included as part of this hacking is talking to the Kubernetes API to get the number of ready instances and the number of not ready instances, the ones that are starting. It is doing some math to calculate that, and it is modifying the specific metric based on that calculation. Yeah, complicated. And this is the metric server. So basically, what it was saying all the time is that it's a metric server that knows about all those pods, how many are being used, how many are available, blah blah blah. It consumes all that metric. It cooks the metric that we need to use, which is the utilization, and then have this metric available to Prometheus server. Just a slight note, Prometheus is not actually pushing the metric to Prometheus. Prometheus is scrubbing the metric from our server. So just a small note. And then the Prometheus metric adapter that I just told you that we forked, but you can use the default one, it should work just fine. That is exposing the metrics to the Kubernetes API. Now, more details about Prometheus, something if you want to start quick and very quick, there is a solution that is the Prometheus adapter, which you basically deploy your Prometheus server, there is a Prometheus operator, and then you need to have service, I don't remember, there is another manifest that you create to register your metric generator to this Prometheus server. So it basically it does all the Prometheus configurations for you for free. It's pretty simple to install and to make it work. And that's pretty much it, I believe. Yeah. Any question until the end? Yeah.
Like the code is open source. Can we find the code on GitHub or somewhere?
For what? For this guy?
Like just for the implementation.
I have a demo. I have a small demo that I'm going to show if I have time. There is another demo that I can point you later on, that a more complete demo that includes how to install Prometheus server, the Prometheus operator. It's not super simple, but it's relatively straightforward. Any other question? Yeah.
Your Prometheus server, does it need to run in Kubernetes itself? Or
No,
maybe like an external server? Except we're using Datadog, which gathers data or something like that. So you can't just pull it from there.
I think right now Prometheus only works, but in the future potentially.
No, actually not really. Because your custom adapter metric, it does whatever you want. So you will need to write your custom metric server. And that custom metric server has the 4 metrics that I exposed. And you just need to provide this data. So the server can go to consume the metric wherever you want, like that.
It should work, but I never heard anybody say it's working with data model. Like I only saw if you do it, you're the next.
Actually, it would be a nice project because I believe there is no custom metric adapter for that adapter. You put what you want. And actually,
There's only one.
yeah, there is
Open source.
But it's not. I can tell you, we have to fork this guy, and it was not the end of the work. There is one interface with 4 methods, and basically the 4 methods is the name of the metric, the namespace, and some selectors.
It's written in Go.
It's written in Go, and then you need to do implementation of that custom metric. How do you get the metrics is up to you.
Yeah, right.
One more question before demo. About the metrics that you have you looked into GPU metrics?
Not really, because our use case is very specific. When we got to this Kubernetes, when to HPA, we said this fits perfect. We didn't have to think about a specific metric to scale. We had already the metric, so that's why we actually didn't use the other one. Actually, what I'm going to do, I'm going to start with the demo, and since it takes some time to run and scale up and scale down, and it will continue answering questions. It's fine? So, let's go back to Linux. Wow. Okay, what we have here, I'm going to have this guy. There is, all this code is in GitHub. Okay, a disclosure on this, I wanted to have a demo, but I didn't have much time to prepare the demo, so I'm not completely comfortable with it. So basically what we have is two servers. I have a metric server. There is a metric server that is a scalable server. This scalable server is pretty simple. It basically is a web server that has two entry points. One that is receiving a request and is holding the request for 10 seconds because I wanted to keep the kind of busy. And it has another entry point, which is the number of current used requests or the requests that have been attended. And there is another one. The other is the metric server that is actually sending a request to this guy, and basically getting the number of those or the kind of the max of the server of the instances. So it's getting the number of the total, and it's exposing this metric to Prometheus. That's pretty simple. So, and then if I show you the manifest, actually there is one manifest for each of them. Each of them is a deployment object that is behind a service. There is nothing interesting there. What is interesting is this specific manifest that contains two things. Service monitor, that was the word that I was looking for. Good? Okay, so what is service monitor? Do you remember that I just said here that you have this Prometheus server that is exposing a metric for your Prometheus adapter? The thing is, you need to tell Prometheus from where it's going to get the metric. Because again, it's not this component who sent the metric from to Prometheus, it's Prometheus who scrapped the metric from that server. So that service monitor is the one that is doing this link. So here you are saying, and this is a CDR or something. Custom definition. CRD. It's a CRD, so this is very specifically for CoreOS. And so it's a service monitor, and it says that basically what is interesting here is you have blah 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 blah. You can define the namespace, the end port, which is basically a service, and which is the name of your port, and the name of the service. So that way it's going to send a request to your service in the port that is being defined with this name, and it's going to grab the metric. Pretty much it is what it does. This specific thing is for if you want to use Prometheus with the Prometheus operator. If you don't use Prometheus or Prometheus operator, this doesn't apply to you.
Sorry, we just had in a Slack channel, we actually asked people how they deploy Prometheus.
Yeah.
So, how do you guys deploy?
Sylvain, you run away. Actually, I can give you my answer, but my answer is not the best answer. Sylvain is the person who actually is installing from the production ready. But we have kind of a proof of concept from a Prometheus server installed with just a manifest file that you get the image. It's pretty straightforward. But I don't think it is very production ready.
Yeah, so most of the people asked, they said they use custom. So, like, I think right now there's two most popular ways to deploy. I mean, you can use Docker or just deploy on the VM, but there's Helm charts in the stable repository for Prometheus. Those ones supposed to be good, but for some reason, people prefer to use CoreOS Prometheus charts. And those CoreOS Prometheus charts, they created Prometheus operator that uses those service
monitor. Yeah.
So like it's pretty much you can go to the CoreOS repository and use it, hoping that somebody is going to continue maintaining it because CoreOS doesn't exist anymore. But like if you see like it's really active, so like the community really jumped on it. So if you guys using it, please contribute back. Ahmed just contributed something to that. So please keep the project going because it's really nice. The operator for Prometheus works very well.
It's pretty straightforward, by the way. It's pretty cool. It works pretty well. And
you can also deploy. You can get it as a service, right? Weaveworks has Cortex.
Yeah. So Weaveworks has a Cortex, and I think nice thing about Weaveworks Cortex is because they have a very good storage. for Prometheus.
Well, it saves you from having to deal with state. Right?
Yeah.
Why would you take that on yourself?
Yeah, we're gonna invite Weedworks to present, hopefully in June, so they can talk about this. Yeah, so but this is, I don't know if it's you have to pay for this or it's a choice. Yeah. I'm more like open source side. I think the
Yeah, you have to pay
operator.
for the storage regardless, right?
All right, cool. So sorry.
So-
the question.
And then this is my HPA object. So I will try to show exactly what it is. So I have is a kind of HPA. I give a name in my namespace. When I'm going to scale a deployment object, call it scalable server. Sorry for the name. And I have at least one replica and at maximum 100 replicas. There is one thing that they want to solve. It's currently the minimum number of replicas is one. You cannot have less than one. You cannot have zero. They want to support zero. And this is the metric definition. So metric definition here, I'm saying is an object. As you can see, this is a list, so you can have multiple kind of metrics. So it's object, and the service is provided by a company called it's a service, and the name is custom metric. So it's my custom metric server who's providing this. And the name of the metric is called utilization, and the target value is spent. So basically, if what can I show you? I can go to Prometheus. This is my Prometheus server. I have my metric here is utilization. The metric here, if I go here, I can do the following, which is if I do this, basically my server, the metric server is being exposed in this IP and this port, and by default it exposes the metric in the /metric. Side note, if you have a Spring Boot Java application, it's not going to be metric, it's going to be Prometheus. And we have some pain on that, because there is already a /metrics for a Spring Boot application that expose other metrics. Just if you have, yeah. And it's not working. It's not working. Yeah, it's beautiful. It's always like that.
It's Prometheus or what?
I believe it's the connection to the services. Yeah, I believe someone should have my notes. So no, actually this is running in Azure, and I believe because we went down, it went down. It was working half an hour ago, so it's not working. So, more questions?
You have a recording or you have a recording?
I will try to turn it on, and if we have time at the end, I can show you again.
Okay. So
yep.
Yeah, just so what was supposed to happen basically?
Okay, basically what it was supposed to happen. Actually, I can show you the record of what I actually have. Is I have here in this screen a client that was sending us a large number of requests, some requests. Then this guy was supposed to show you the metric that was being get by the metric server. And then after that, you were supposed to see here in the graph in Prometheus how the metric went up and down. Basically, it went up when it went up when you have more requests, and it will get down when you have less requests. And then here is I can show you this. This is if you do the stripe of the HPA, this is pretty much what you're going to get. So what you are going to get is it's actually something that looks like this. And it's basically going to say what is the specific metric that is being used, what is the minimum number of replicas, the maximum number of replicas. And this, I always had issues to understand this guy, but basically what this means is that what is the specific status of the HPA. So it will tell you, for example, if it's able to scale or not based on if the warm up and cool down period was actually passed. And if he was able to get the metric, of course, it's not saying that it's not able to get the metric because there is no service running. And that's it for this guy. And then here you were supposed to see how the pods get what we're getting up and down. No, it's not working. No, I don't want to drink. No, it's not working.
Let's just scroll down.
Yeah, it just.
Yeah, cheers up for.
Sure. Is anyone have any more questions? There's one question. Couple of questions. Sorry, I didn't get that.
Could be the targets for the metrics, something else than numbers. Like I saw you put number 10, could be string or like a array.
No, it's actually number. It's actually number. Yeah.
The same type of question. What is, when you have a number and you have a delta between the target and the measure, what is the formula and who's deciding the formula of how much pod you're going to scale up or scale down?
You are my manager. Why you are Why are you asking hard questions? What was the question?
So let's say you got a target of 100. And you are measuring now, and it used to be 100, 100, so you got your pod, it's constant, nothing moves. Now it goes to 200. What is the formula that determines the amount of pod that you're going to increase or decrease? Is it hard-coded in Kubernetes, or it's...
Ah, okay, yeah, I know what you're asking that question. Yeah, okay, thank you. This is the equation. Come on. This is the equation. Basically, there is no equation to say it's going to scale that number or reduce that number. This basically is going to tell what is the new number. And one of the problems we had is that we wanted actually to have our as metric, not a metric. We wanted to have as metric the number of pods. We were able to know how many pods we need. Because of that, we were in this one. You cannot play with that. This is hard coded in Kubernetes. Something that we would like to have it say, you know, you have a nice equation, but I want to myself decide how many replicas I want to have.
Excuse me, is there a maximum number of replicas?
Yep, it is actually here. You say minimum number of replicas and maximum number of replicas.
No, this maximum number we got, but is there a limit for the maximum number of replicas?
How much memory do you have?
Or how many machines you have? Yeah. Yeah, yeah.
If you want to update the number of replicas you are running.
Okay, sorry.
Would you like this to the formula? What if I have several metrics?
Several metrics is going to
how should I use this formula?
Because every metric is going to calculate a different number of replica counts, and it's going to use the more conservative one.
The biggest one.
The biggest one.
It could be viewed as least conservative.
Okay, yeah. Let's say the one that requires more pods. Yeah. When you say conservative, is because you want to have as many pods.
So if you know the current replica count, you cannot just update the manifest and make a new API call and just automate this and avoid the headache of having.
If you'd rather have the headache of doing it manually.
Actually, so we at one moment when we were facing the problem with the warm up, we said HPA is quite simple thing. You just need to run. You know the number of replicas you need. You could just kind of do an update of your manifest, say how many replicas you need.
So you could use a CRD with a custom controller if you want to do that.
Exactly.
If using HPA, you just write your own controller and write your own logic. Reason on our side, I think why we wanted to stay close to Kubernetes and try to contribute, and there's a lot of logic and subtlety. If you do that, you have to start making sure that you got all these cases. While if you use HPA, then hopefully you take advantage of the error and the bug fix that other has done.
How does the HPA interact with the pod disruption budget? Pod disruption budgets?
It's supposed to start with budget, so yeah. So
you can help me there.
Yeah, so
Pod disruption budget is, for example, you're doing the upgrade of Kubernetes one node after another,
and you can set for the structured budget that's saying you cannot upgrade this, you cannot delete this node, for example, because there is some workloads running on it and it's important. So you're saying you're not supposed to delete this node.
It will prevent the drain.
So HPA has no impact, right? Whatever what disruption of the jet does, HPA is just running on top, right? Because
basically, yeah, SPA what it's only doing is changing the number of replicas for your object. So that's pretty much it.
it's equivalent of if you would say that
Scale.
deployment and scale.
It's the same on the scale.
I have many questions actually. Who is here able to configure, except once, configure HPA in your clusters? Is anybody?
Me.
Alex, you did it. Who was able to configure custom HPA on your Kubernetes cluster? Can you share the experience?
Well, I took a look. There's manual versus control. We patched a few things. I think this is still a work in progress. We have run onboarding task 2, which is a pain because we also have to deal with the order of killing that we don't. So we're trying to work around this with the grace period for now, and we're still having questions.
Good job. You want to share your experience?
Yeah, in production, we're mainly using HPAs using the normal metrics. We have about 30 to 40 HPAs running in each environment. You do a pretty good job once you get to size your request or your clause properly. I did some experiments with custom metrics HPA when it got out. It wasn't stable enough for me, so I stayed and waited until stabilized, but I'm pretty happy to know that. I used a previous version of the custom metrics server. So I had to push metrics to that server in order to be able to use them. It worked too well, so I guess this solution is out there.
So we have another 2 people in Montreal who did it, or 2 companies. That's pretty cool.
I have a question. I want a t-shirt. You know, I'm kidding. No, I'm kidding. Any more questions? No?
Yeah.
Sorry, nuance. Yeah, not being embedded systems. Yes, as quite new to cloud. Just wondering if you have any performance issues while using cloud. To me, like cloud cannot guarantee any performance to my understanding, especially that when you say that you take as you use. So to me, it's like a question that if you have experience with that.
So we have very nice Kubernetes workshops. You can come and we're going to explain. This is like the whole story. Before getting to the HPA, of course, you need to understand resources. Many things kind of part of the picture, right? So it's a very wide question, but it's very good if you join the workshop. You can definitely explain that. So one thing, for example, is if, let's say I have a company like HBO and running Game of Thrones. Do you think HPA is going to help you or no?
Yes, and actually our use cases, we have a very specific use case that it's at some specific hour you get a very big spike. And on that is when the airlines calculation gets in, because it kind of allows you to kind of predict how many replicas you need to have. If it works for our case, it will work for, I would say, any other case, because this warm-up period of 30 minutes is a pain, really painful. So it forces us to kind of predict how much traffic you're going to get at a specific time. So that's pretty much your use case. There is one thing though that we plan to do. We didn't do it yet, but we plan to do is kind of, this is reactive. This is reactive. This basically is reacting in your current traffic. We want to have a predictive one, and this is where the HBO case is going to get.
Yeah. Yeah, and another problem, a lot of people complain for the HPA that it takes sometimes you have like spikes and you want to make it faster. You said 30 seconds by default?
Is 30 seconds by default to kind of recalculate, but then is what is in this period after they scale down and scale up. So what you may face is that the spike, you got in the first part of the spike, and then it scales up a little bit. But then in this period that is not doing any scaling, you have a big spike. That is going to be a problem.
Because I think the way it works is gonna, let's calculate, add one replica, another replica is gonna be, you can always add 10 replicas in one shot.
No, actually what I wanted to show was that you can scale 20 replicas in one shot or 30, because it's not, again, the equation is not telling I'm going to scale 1 by 1 or 2 by 2.
So it's proportion to the relative to the progress that you made, so the gap between what you target and the current.
Exactly. What I wanted to show you was exactly that I wanted to pass from 1 replica to 10 replicas in one shot. So that is not a problem. The problem is that you pass from 1 to 10, but actually you need to go to 100.
Maybe it was the issue with the hipster.
Yeah.
Maybe Prometheus.
For Prometheus is not a problem. I don't think so.
All right, I think we're gonna pass to the next presenter. If you have some questions, we can still take them. So not kidding.
I just want to ask if you face any issue with the stability of the custom server, the custom metric server.
To be honest, we faced issues with this stability of this server, but it was because of us. So I hack it, so we hack it, and because we hack it, we faced issues. But if you start the default one, it should be fine.
Still not in production, right?
Yeah.
Do you guys use AKS and use your own Kubernetes?
Sorry?
You use AKS or your own Kubernetes cluster?
You know the answer. You know the answer, right?
You guys have it?
Thank you very much.
Bravo, thank you.
Yeah, it's only on my laptop. No, it's only on your laptop. Okay, never mind, never mind. Oh, sure. How does it work? USB?
Japanese. Nice. It's going to be Japanese presentation.
Yeah, it's on the picture.
Which one?
Just close out upper left-hand corner.
Sorry?
Upper left-hand corner. Just close out the keyboard assistant. You don't need that.
Okay, okay.
There you go.
And yep. And the pointer?
No pointer, just left and right.
Okay,
No, this one there's a laser. It's not on T. Okay.
Cool. That's it. No after the break. So we start around. Cool. So thanks for attending. Sorry about the coming in issues if you had any. First time doing this. So I was supposed to do a lightning talk, 10-15 minutes max, but since we have extra time, I'll take my time. I wasn't going to go into much detail compared to Louis. So what is the talk today? Avoiding communities meltdown in Azure. So some people found it funny. I heard people using the word meltdown in the title. So it's going to be first of all, Meltdown Spec Vulnerability 101. To be honest, if everyone knows, anyone doesn't know what Meltdown or Spec is, the vulnerability, I have know. So I'm going to be skipping that slide. That's good. Fault and update domain in Azure. Details on that. Details on Cloud Affinity and T-Infinity and Kubernetes. What's the problem and how did we solve? Well, to be honest, we didn't solve it. We just weren't affected by it because we actually had all this in place before Meltdown. So. Quick about me, wear many hats throughout the past years.
QA, load testing, framework information, then move to application specialist, software developer, monitoring stacks, DevOps, Agile, Kubernetes containers. So, touch a couple things. Or now I kind of like the open source area, being able to participate commits and help the community. So you might see this similar face on GitHub, DJ slide on GitHub. So I'm skipping this. The only thing we need to remember is what's the whole point of this? It actually caused our VM to be rebooted within 2 days. Actually, no warnings, right? No, like, hey, the vulnerability is out. Like, to be honest, okay, yes, it's out. What do we need to do? When are they going to reboot? I checked, they rebooted my VM, right? It was literally that fast. And the main reason was because because of the hypervisor issue where VMs could access data from different VMs, which is owned by a different tenant, right? So they had no choice but to rush the patches. So this is general. How do we achieve in general high availability in Azure? Any Azure plus cloud users here? Okay, a few. AWS? Double, triple. Google Cloud? Same on AWS. Okay. By the way, it is sponsored by Azure. You got some free trials, right? So, for those familiar with cloud providers, you have the same concept, I'm sure, in AWS and Google Cloud. I'm just not sure about the update domain, so that's the one I'll be focusing on more. But first of all, there is this availability set, which defines a group of VMs that Microsoft will give you SLAs for. So they will ensure that all of the VMs within that availability set, they will never go down at the same time. Right? So then this is enforced by the failure domain and the update. Failure domains can be translated to a rack in the physical data centers. So, and they're really due to hardware issues. They lose a switch, they lose a power supply, or the rack just goes down. So that's your failure domain. From 1 to 3, some regions it's 1 or 2, and some others is 1 to 2. Update domains now, what are they? So define a group of VMs again, but this time is a group of VMs that Microsoft will issue planned scheduling of reboot. So if they need to apply a kernel patch on their hypervisor, they will target VMs that are on separate file domains. So I like to use the equivalent as a chassis for those who are used to blades and chassis in a rack. So they will target different chassis when they perform the upgrades. It can go up to 20 in some region, and I think, yeah. So, and some pictures explaining.
What about the availability zones?
Availability zone is, too new. But they're starting. I think it's in preview now where they actually have cross-regional support for SLAs.
So that's why we have to use those.
Right now, in Kubernetes, if you use AKS, if you use ACS engine, you are using availability zone. Availability sets. The other thing that Azure supports is VM scale sets, which basically is, I don't know the equivalent in AWS, but it's you provide your bootstrap logic and you say how many VMs you want, and they will scale it up and down for you. So this is coming in 110. The support in Kubernetes 110, just a scoop to next meetup, will have Azure VM scale set support. So AKS, ACS will probably start moving to VM scale sets. And this will allow us to move into cluster to scale, which could be a totally different talk, which we can move on. Okay, moving on. Enterpod, Affinity, and Affinity, what are those for? And how do we use them? So this is a pure Kubernetes feature. It is for detecting or identifying where your pod should go on which node. So it could be seen as the node selector approach. Where are my nodes? My pods supposed to go with respect to nodes? It was released with 1.4. It is beta with 1.5.16, and it's still on beta. So I like the second line. So it allows users to constrain which node your pod is eligible to be scheduled based on labels on pods. So you're not using like node selector labels on nodes, you're using labels on your pods. So there's both two types of requirements. There's the soft and the hard requirements. Soft, that is basically, do you prefer during scheduling or do you require it during scheduling? Those affinity. And you define this within your manifest at your pod spec level. You will define an affinity spec, pod affinity, and then you're required during scheduling section. More details, I'll provide that after, you can read more. So that's fine. Those are affinity rules that you define on your pod, either like a pod affinity or a pod NT affinity. Each affinity comes with a weight set. So you could have multiple affinity for your pod, and you can say, I want you to, you can tell the scheduler, I want this one that you favor more. You put more emphasis on this one. This one is more so, you know, at best practices. So this is the full complete example. I don't have that. So after the weight, you basically give the label selector for your pod that you want your pod to match, and I'll explain more in details. And your topology key. Topology key is, this is the information that is associated to a particular node. So in that case, we're looking at the node host name as part of our affinity. How can we read all this? Well, this pod, in this case, it's an empty affinity. So this pod should not run in an X, where X is your topology key. So this pod should not run in a node with this host name. If that node with this host name is already running one or more pods that meets the label selector. So I know it's you know, lots of wording, and I don't know why I put an issue there. That's probably not where I wanted to put it. Any questions on moving fast? Because it's supposed to be a lightning talk. I'll wait for advanced questions. Any other questions? No? I know it's probably not clear, but I'll go more in detail.
So those affinity you probably using something stateful, right?
No. No. I'll explain how we leverage it yesterday.
So for the weight, what it's used for? Because okay, you say you got a weight, but relative to what, right?
So if relative to other affinity or relative to any other affinity rules that you have for this pod. So if you have multiple affinities, you will want to say, I want you to make sure that I want you to prefer scheduling this pod on a different host name versus scheduling this pod on a different zone or a different region. So if he has to make a choice and they're both equal, he will favor the one that has more.
So this is the weight of
this. Yeah, this prefer during scheduling. This is with this topology key. That's the.
Do they imply you may have multiple rules like this?
Like correct. Yeah. So you have. I'll have an example where I have 3 of them. Okay, so we have a problem now. So what is the problem? So HA, I explained to you availability sets. Those are nice. I'm going to go back. So they were made for interior type of application. You have one availability set for your front end, one for your web tier, one for your back end. And then this allowed those VMs to, you know, if I lose one, I'm fine, I still have 2, and if they upgrade, I'm not losing my back end, and so on. Now, this was a manual deployment. I'm deploying my VMs, I'm choosing, and I'm setting the application on the VM on those particular nodes, right? So now we bring Kubernetes in the mix, which brings in its own scheduler, which is not aware of Azure at all, and availability sets either, right? So what can happen now is, at the bottom of my masters with my schedulers, a pod comes in, Kubernetes will say, okay, I have this node, it has full CPU, full memory, let me put it there. Oh, I have this other node, full CPU, full memory, let me put it there. It's a different node. I'll try to do a spread out because that's what the scheduler tries by default, is spreading out your pods across nodes. But how can Kubernetes guarantee you or ensures that those pods are actually on different fault domains and update them? So this is where you'll need to enhance Kubernetes and bring in the information for them to say, by the way, when you schedule your pods, I want you to not only look at hostname for spreading pods across, but I want you to look at failures and update domain, which are data coming from the Azure cloud provider. Any questions on this? Yeah. Okay. So how can we achieve that? So this is where we're gonna try to augment the scheduler with our pod affinity and infinity logic. So yeah, by default, the scheduler is sort of working with the Kubernetes cloud provider operator, and he is aware of a few concepts, which is the zone and the region. So if you deploy Kubernetes in Google Cloud, AWS, or Azure, you will actually have this zone auto-magically populated on your node. So I lied when I said that Kubernetes is not aware of fault domain and update domain. Kubernetes is in fact aware of fault domain only. Because the update domain seems to be, well, at the time, I started reading that Google Cloud is introducing the same concept, but update domain was an Azure specific, and I think that's where I brought in the issue is people were requesting about how can I make my cluster aware of these update domains. So this is one thing. Now, also by default, the scheduler, as I mentioned, is going to spread out your pod based on those priorities. And they all have, this is the default settings from a scheduler point of view. This is, I put it in the code. So it will apply the same weight, either if for interpod affinity, for node affinity, balanced resources allocation. So if you want to balance your pods across all your nodes, least requested, the node that has the less requested, the nodes that have pre-cached the images. If your pod image is already present in the node, the scheduler will probably favor that node as well. So all these by default, they are all of equal weights. So something to keep in mind. Now, update domain, as I mentioned, as you can see, those are labels on a node by default on Kubernetes. So you will get your failure domain zone, full failure domain region, which is the Kubernetes cloud provider that populates this. Actually, when Kubernetes starts, it populates those labels for you if you run in a cloud provider. So those are just examples. And those are the issues where we talked about how can we have this update domain that is missing auto-populated for us. So still unresolved, long discussions, fights across Kubernetes, Azure, guys, fun stuff. So how can we solve this problem now? That how can I make sure that my pods are not being restarted on all of the nodes at the same time? So what we did for the update domain while we're waiting for the community to come up with the best solution is we have the luxury of not running AKS, to answer the question, and ACS, so anything. So we're deploying Kubernetes vanilla within an infrastructure. So we bring up VMs with Terraforms, we install with our own installer Kubernetes, and we're running kubelet natively through the system. So we augmented the service file with an exec start post with an Azure label creator shell script. This is a really stripped down version. It contains lots of retries, lots of HTTP proxy logic, and name it. But in the end, the core logic is we're curling the node's metadata for the update domain because, thank God, it is present on the node through the metadata URL. So we're curling that, extracting the UD, and then we're just calling kubelet with a labeled node that we're running on. So we're automatically applying the update domain on kubelet start. Any questions here?
So all the nodes have this information.
So all the nodes now, I showed you before the labels. Now, as you can see, we have Cloud Azure Beta Kubernetes.io UD2. So now I'm in ECUS2, Zone 1 for my failure domain, and update domain I have 2. So I do have now this information available for Kubernetes to act on when it does the schedule. That is not too bad. I was wondering how it would show up. So this is the sort of our stripped down, because we have more logic also. Like I think we have 6 or 7 affinity rules, but right now I just stripped it down to zone UD and hostname to simplify the example. So as you can see, each of our manifests are actually being augmented with those affinity rules. I believe in recent, I forgot the name, I can't remember, the auto-injector. So we might look into auto-injecting this in our manifest.
Initializers.
No.
There's spot preset, but that's not what you're talking about.
But there is a way now you can tell your API server, like, hey, by the way, when you receive a manifest file, give me a second, I want you to inject this data. Yeah. So instead of having our team who manages all these M charts or name it, and forcing them to integrate all these, we will eventually look into having it auto-injected. But for now, this is everyone who deploys. If you want to have the support, you should apply these affinity rules. So quickly, those are 3 anti-affinity, and based on hostname, update domain, and zone, and they are using a special label with the app group ID. So when I deploy an app, it comes with an ID, and I just make sure that it applies and that the pod has an ID, and I want to make sure that my pod, similar pods, fall on different zone, different UD, and different hostname. As you can see, I have a weight which is 100 for my hostname, and then the zone and update domains are at 10. Sure. So verbalizing all this, pod should go on nodes where the same pod isn't running, and must favor nodes with different fault and update. Now, we put all this in place, well, again, that's it, that's easy, right? Didn't work. Just didn't work. Never went on that node that we needed it to be. And this is where we understood more that this is where the equal weight set comes in. So as I showed you at the beginning, the priorities were all equal. So you could augment your scheduler. You can tell them, by the way, here's the policy config I want you to use. Don't use your default of everything is equal. I want you to put priority on node affinity and enter pod affinity. And just by setting those weight a bit higher, by the way, the 10,000 is the default in Kubernetes, but by bringing up the 2 at 250, then everything worked magically. So all the pods were scheduled on different combination of FDs and UDs and hostname. And if you have 20 FDs and 40 pods, you will end up with 2 pods on each of those UDs. So, yeah.
Why do you think it didn't work when all the weights were equal?
Because the balanced resource allocation was sort of being favored, and it was just saying, it was pitching the pods on nodes that were more less used. The less used, the least requested party was favored. So he was saying he's trying to balance as much as possible your weight load, but in some cases you might have bigger pods on. So
is it fair to assume that these numbers you have there, the scheduler take that as input, plus the weight of the rule, and calculate a value?
Well, no, because the weight of the rules are defined within interpod affinity. So he knows he needs to favor more the interpod affinity. And once he starts favoring those, then he looks at what are my weights across my affinity rules. So it's like a 2-layer.
Finance was telling me that was having a mathematical, like these rules, this theory, was summing, like taking this as input, calculating an index, and then saying that's the amount, and based on the biggest amount, this is where it's going to be scheduled.
Could be. Could be that he's using the 250 as a multiplication factor for the other weight setting. You had a question?
That was the question.
That was it. That's good. All right. So now I can have Microsoft reboot my VMs and oh yeah.
I just want to mention that nuanced communication is always one of my favorite examples of successful companies in Canada using Kubernetes. And what I like a lot in Nuance as well, that they do a lot of upstream contribution. So they want to seek Windows, seek Azure main contributor. I think you were writing it on the call sometimes. So this is a good example of initiatives that our raw Canadian people doing it. So try to contribute back to Kubernetes community, and if you can, then that's that'll be benefit to everybody. And like I just see huge improvement in terms of with Azure and Kubernetes, because I remember a year ago when we talked, it was completely brownfield. Greenfield, now it's already AKS, ACS.
Yeah, but for just to complement two things, yes, Nuance is a great company, and we do have open position if you're interested. DevOps, cloud, and also feel free. We have some people around, but this is not a recruiting event, so we're just giving you some insight. Yeah. Second is participating in SIG. I really recommend. To be honest, I'm not defining the Microsoft roadmap, but I'm influencing it by some factors. If you bring up issues to the SIG, they actually are developers like us, and they are okay, cool, that's how you use it. Okay, let me bring back your issues to the dev team and let us see how we can do it. And they provide us inputs that even the official Microsoft website won't even say. They are forking Kubernetes. They said that it was supposed to be 1.10, it's going to be 1.11. They will be forking Kubernetes to accelerate with PRs that are specific for Azure. Because right now, sometimes bug fixes on the Azure side is taking too long. So they want to fork and then just merge back to upstream, but at least they'll be able to contribute faster to the community for bug fixes. So those are inputs that are oh, we were shocked at doing, but at least we know in advance. And we don't have to be surprised if they do it. So I really encourage you to join SIG AWS, SIG whatever you feel SIG networking, SIG instrumentation. That is very beneficial, I believe, for you.
Oh, thank you. So
can you share your experience migrating from
we're still running there.
I think you've been there in Kubernetes for a while.
So what was the question?
Migration from on-prem VMs to Kubernetes?
On-prem VMs to Kubernetes? We actually are still running on-prem, by the way. So that's why we have our own installers, because we use it for both on-prem and Azure. So, but then if your question is how do we move from monolith, or I would say static, to Kubernetes?
Your experience, moving from
that can take a while. I think what you guys can take have a year together. Then time we're gonna have guys from Mesos here. Yeah, and this is another nice scheduler, and we're very happy to have Mesos finally, because there was a huge interest when we started the first meetup. I remember we had the guys who was using Mesos and trying to run Kubernetes, and now we have actually Mesos here officially have their own Kubernetes solution, and that's what I think they want to show us today. So I'm very happy that we're gonna have them and T-shirts, swag, please be active. You can get something for yourself.
Thanks for once again for hosting us.
Can everybody hear me? Okay. Quick question, trivia quiz. For a t-shirt, why does this have 7 points on it and not 8 or 6? Go ahead.
So they have 7.
Is it because the first original project is called Borg, and then they forked it and called it 7, and then it became Groove?
Do you know why it was called 7?
Because 7 of 9 was the first Borg to be friendly.
And it was supposed to be a more user-friendly.
Yeah, is that it?
Yeah, that's exactly right. The only reason I know that is I went to Wikipedia.
Thanks to Archie for that information.
Oh, come on.
Well, he didn't tell me today.
Oh, okay. Okay.
You guys have free PlayStations today, or Xbox?
Sure. Just give me your email address and your cell phone number, and I'll get that right over to our inside sales person. Good evening. Thank you for sticking around. It's time for the vendor talk. So
So I've only got about 75, 80 slides to get through before you actually get to see live product. Just kidding. That's flickering? Okay.
Oh.
Meltdown. Power and give me 1 second. So maybe while we're getting this set up, Mike can introduce himself and thanks everybody.
Thanks to all of you for staying late through this. Appreciate everybody taking the time to learn a little bit about DCOS and Kubernetes. We just recently released the version 111 of DCOS that now supports Kubernetes as a generally available offering as an open source as well as an enterprise offering through Mesosphere. So we'll talk a little bit today about what the capability is and why companies are taking a look at running Kubernetes on DCOS. Feel free to ask questions again as we go forward. Let's make this interactive. Ed?
Yeah, absolutely. Thank you. First off, this is not corporate branding. This is my attempt at putting together a pretty slide. This would work. And it's technology. Yay. So why don't we just do this? That's not working either. Okay, so what we're going to talk about tonight, quick overview of Mesosphere DCOS. Why would I want to run Kubernetes on Mesosphere? Why wouldn't they just run it on bare metal or in some cloud environment? We're going to take a look at deploying Kubernetes on DCOS, and then we're going to actually take a look at DCOS from a UI perspective and how you can do things. Cool. Perfect. Thank you. Plain Jane Kubernetes. And then we're going to talk about how to get started with Kubernetes on DCOS. First off, we've been a big contributor to the CNCF for a long time. We were actually one of the first groups to try and implement Kubernetes as a scheduler into DCOS. We had a tough decision to make a while ago. Do we go with Marathon or do we go with Kubernetes? We made the decision to go with Marathon. Kubernetes is back because it is the most popular scheduler out there, and our objective is to be an evergreen platform on which to deploy any workload you want. So you look at a little bit of the history. We really got our start in 2010. Kubernetes came along in 2014, which was when we started dabbling in it. DCOS as a product was launched in 2015. We are an open core product. That's something to remember. Most everything we're going to be talking about tonight is part of the open source solution. So you can go and download this and install it in your own cluster or install it in the cloud tomorrow if you'd like to. This is not something that you will need a product license. We would love to sell you the enterprise version, but this is something you can do with the open source version as well. 1.11 brought a lot of neat new features to DCOS. Number one, Kubernetes as a service. We like to call it one-click deployment of Kubernetes. Is really 3 clicks. Seamless, but it's one command line. Seamless cloud, hybrid cloud operations. The ability to deploy a cluster to multiple clouds, whether that's your cloud, Azure, Google, AWS, what have you. And we've also added some security things, such as being able to have different clusters trust each other, encryption from node to node, as well as binary secrets that allow you to quickly and easily secure your services as you run them. When you look at DCOS, our focus has always been on broad workload coverage. What does that mean? We've always supported containers. We've always supported Docker containers with Marathon. We also give you the ability to run what's known as a Mesos container. You don't have to go through the entire process of building a Docker container. You can actually just bundle up your artifacts and run it within a Mesos container without having to go through the process of your Docker file build. We also support a lot of data services. There's been a lot of conversation tonight about state and statefulness. That is something we do very well native to DCOS that some people would say Kubernetes has not been great at. We also provide automation and management of these things. And we're going to see a little bit later how we can actually help to manage Kubernetes
So if etcd goes down, or if we want to scale out our number of Kubernetes nodes, we can do that. And the ability to pool resources, whether it's bare metal, whether it's VMs, or whether it's cloud resources, bring them together as one pool of resources so that they can be intelligently scheduled and allocated to whatever applications you're looking to deploy. So really quickly, why would I want to run Kubernetes on DCOS? Well, we're kind of biased, but we believe it's the best place to run any workload. Legacy Java apps, new containers, old containers, whatever it is, if it can run on a Linux platform or it can run on containers, Docker containers, we can probably schedule it with DCOS. We are not giving you a fork version. You would actually be pulling the plain Jane vanilla Kubernetes from Google or from GitHub to actually deploy this. So we're not going to force you to fork over to a different version. We're going to take care of a lot of those hard things like networking, storage, secrets as part of the deployment process. You don't have to go out and build it yourself. We'll actually do that as part of the deployment. Fault tolerance and scalability, we've talked about that a little bit. We also give you the ability to choose your ingress and egress platform. If you want to use traffic, if you want to use our EdgeLB, if you want to use Kubernetes as native inbound, outbound capabilities, we can do that as well. And the big thing people have chosen DCOS for in the past has been data services. The ability to run your stateless containers side by side on the same network, same namespace as your data services, your machine learning, and your AI platforms.
Could we ask a question along the way or with the team?
No. Go ahead.
So, when we install Kubernetes, we usually have cloud provider integration.
Okay.
We install Kubernetes in Azure, and then there's some plugin to have it seamlessly integrate with load balancer, for example.
Sure.
So how does that DCS handle that? Is that because you said you installed vanilla Kubernetes, so does that mean that this vanilla is integrated based on the different cloud provider, or you understand what I mean?
Yeah, I was just waiting for you to finish. Yeah, so like I said, all we're taking from Azure or AWS or whoever is compute. You set up compute, you lay down DCOS as the first layer, and then we will deploy Kubernetes on top of that. And we'll go through a video in a moment just to talk about how we can do that. I thought we were only going to have a few minutes tonight, so I actually took a time-compressed video of the deployment process from 5 minutes down to 1 minute in order to save some time. I like this because Kelsey Hightower actually said, yes, it's gotten better, but you would still run stateful services on something other than Kubernetes. So let's take a quick look. Kubernetes the hard way. You guys have probably all done this. I haven't, but you guys might have. To deploy all of these things, all these individual components, that's what you got to do. Any questions so far? So let's take a look at the video. Well, we're video first. This is not live. This is because I had to compress it down to 5 minutes. So what we're doing is we're going to the catalog, which has kind of like Helm. We're doing a quick search for Kubernetes. This is on 1.10, where it's still in beta. And first thing it does is deploys the Kubernetes parent process, which is going to manage Kubernetes through the deployment process. See the clock in the upper right-hand corner. First thing that happens then is etcd gets deployed. We can either deploy etcd in a high available capabilities or just a single node, depending on how you want to do it. Once those are up and running, we're going to deploy the API server. And this is all happening without me actually doing anything. This is truly the one-click deployment we were talking about. Schedulers, and now we are on to node 0 for kubelets. So this is the first node up and running. Second's coming up. Clock starts to spin because this is when it takes up to 5 minutes. It's typically about a 5-minute deployment process if you're just deploying a 3-node cluster, which is what this is deploying. We're also going to be deploying some of the add-ons, so the dashboard and Heapster and QDNS. But that's just a quick look at everything that goes into deploying Kubernetes on DCOS. All of it happens as part of the framework. When you want to get rid of it, just run that command. Actually, in the current version 1.11, you don't even have to go to the command line. You can get it from the. So that's a quick look at deploying DCO or deploying Kubernetes on DCOS. I don't think it could really be any easier. So let's go ahead and take a look at the GUI for a second. So get out of there. Yes, please. It's not necessarily based on a specific Linux version. We support CentOS and Red Hat, as well as a specific version of CoreOS. We have lesser support for other versions, but Red Hat and CentOS are the two ones that we primarily support.
And when you say it's open source, it's based on which open source license, so GPL or?
It's based on the Mesos. It's based on the Mesos framework, which is an Apache framework. So I don't know which open source. That would be the Apache license. So right now we have an application running, and I'll get to it in just a second. These components are running in Kubernetes. These components are running in their own frameworks. We'll get into in a minute talking about what a framework is. And these guys are running in Marathon. We have a connected car app that is receiving feeds from fake cars out there and telling us information about the drivers, the cars, where they are, how fast they're going, things like that. I want to take a quick look at what's going on. I can quickly see within my cluster how much of my CPU has been allocated, memory, disk, etc. What is the health of my individual services and the individual nodes that I may be running. The nice thing is, though, I didn't actually tell anything where to put it. DCOS determined where is the best place to put things based on the offers coming in from the different nodes. We talked a little bit earlier, I don't think I mentioned, there's actually a 2-level scheduler. There's the demand from the applications, or the demand from the workloads, and the offers from the machines. The machines offer Mesos, CPU, disk, and RAM, and the frameworks request them. So here we see the intermingled workloads of the different processes and the different frameworks we have running. Now, when we talk about a framework, what is a framework? Well, a framework is some automation around a specific application. Kubernetes is a framework to us. We also have frameworks around CI/CD platforms, such as GitLab or Jenkins, that I would use to run my source code repository as my builds, or my builds. I might also have data services such as Cassandra, Elastic, Spark, Kafka, all running on the same cluster that are doing short-term as well as long-term storage for my platform. But inside this is Kubernetes. So, or what's running the stateless services right now is Kubernetes. So here we see, I think we've got 3 kube nodes up and running right now within this cluster. Let's take a look at the configuration and scale it out a little bit. This is where, when we go through the initial deployment, I would choose what do I want to call it, how many etcd nodes do I want, how many processing nodes. I'm going to go ahead and take this up to 4. So what I've just done is I've changed the number of kubelets that are out there. So it's checking, it's saying I don't have 4, so I need to add another one.
How's it going to resolve quorum?
Hmm?
How's it going to resolve quorum?
with the kubelets.
With an even number of etcds.
It's, I'm sorry, did I say etcd? I didn't mean to say etcd. I meant to say kubelets. We've only got three etcd nodes out there. Yeah, that's, did I say etcd?
I might have misread.
Okay. So what we're actually doing right now is we are in the process of deploying, and it's showing unhealthy right now because it expects to see 4 nodes or expects to see 4 kubelets. It only sees 3. So it's going to go through the process of making itself healthy. While that's coming up, I'm going to go take a look at something else. The nice thing about this is we're using the same command line tools that anybody else would be using for Kubernetes. So if I ever wanted to see something like, how many nodes do I have? Or what are my nodes that are up and running? Well, here we are right now. If I wanted to see pods, I'm going to do type or some. Use the pods that I have up there and run them. Let's take a quick look at, say, this guy. We'll see. Okay, let's take a look at Cassandra. So what we see here is all the information about the Cassandra ingester for this application. Now, one of the things I wanted to point out is, notice the IP address, 9.0.3.4. Where did this IP address space come from? It actually came from DCOS. So we're actually using the same IP address space as the data services. So it's a lot easier to allow your Kubernetes processes to talk with your data services and your CI/CD platforms as well. There are things that are living outside of Kubernetes. So that's one of the things that we handle is the networking capabilities that sometimes can be tricky to take care of. Let's go ahead and kill etcd. That's always fun. Everybody loves killing etcd for some reason. So what we're going to do is we're going to go in, we're going to look at the etcd node 1, and we're going to go PS. So here we see what's running on that node. We have the Mesosphere process running, and we see etcd on this node has a process ID of 3, so -9. And it kicked me out, but that's okay. Because what we can go in here and see is updated. You saw it go orange and then green. We were actually redeploying etcd. And if we take a look at all tasks, completed and active, we'll see here that this guy failed. And this is where the framework and the automation comes in for making sure that everything is healthy. So that is the definition of really what a framework is the automation built around a specific type of a workload. So whether it's Cassandra for data, whether it's Elastic, whether it's Kafka, Spark, Jenkins, Git, Kubernetes is one of the frameworks that we support from a management perspective. I think I've covered most of the things that I wanted to cover today. So really quickly, I'm not done yet. No, I've got to have my call to action. So what I'm going to ask is, if this was at all interesting or you thought any of this might be interesting, go get the bits. You can download it today if you want to. Join the community. And where it might go. You get to determine who gets the t-shirts because I gave one of them away, so you get to give the other few away. I'm sorry? Yeah, thanks. Are there any questions from the crowd? I know it's been a long night. Yes?
Which network plugin are you using? Are you using something like Calico or a custom one?
We are not using Calico. Good question. Yeah, give them the T-shirt. We're actually using our our own networking. It's going to be moving to. One moment.
How's the docs?
Huh?
Documentation.
I'll give you my number. Give me a call. It could be better, but the way I got started is there's actually a Vagrant install, which you can use if you've got a big enough laptop. With VirtualBox Vagrant, it will pull down and deploy the entire cluster for you locally. That is what I would, if I just wanted to play around with it, that's the first thing I would do.
Since I have the microphone, I will speak louder here.
Where? Okay, go, yeah.
Compare with, against OpenShift.
No comparison.
What do you mean?
It's better.
You can run OpenShift inside your product, or it can do the same.
They are very similar. They are seen as being the same. I will give you my personal opinion. There is less infrastructure to get this up and running than there is OpenShift.
Yeah, but with OpenShift you can use Ansible playbook and you will install something.
You can use Ansible playbooks with this as well.
We're also using the OpenShift.
Yeah.
I think OpenShift is more considered as a Kubernetes comparison.
No, there's a lot of comparisons.
From the demo, I can see that it's similar what you have to do.
Yes, there is one less layer of infrastructure though with this. We don't require OpenStack or anything like that from a hypervisor perspective. And sure.
So how easy is it to add frameworks, basically? That's like you had some demos there, last week or whatever. But if I want to add my own application as a framework that's automatically maintained and respawned and whatever, like what are we talking about here? YAMLs, or scripts? What are we talking about here?
Yeah, I'm trying to get out a full screen so I can go to it. So that's a good question. Yeah. I'm just trying to remember which tab that was in. So, catalog. We've seen a few. There's two different types of frameworks that have already been built. I'm going to answer your question directly in just a moment. There are what are known as certified frameworks, which have been built, tested, and are supported either by us or that third-party vendor, like Confluent or DataStax, or somebody like Elastic. There's also the community-based frameworks, which have been built out for by the community. So there's over 100 of these. Now, if I wanted to deploy something, say, from GitHub, that's kind of what we've done here within our own package. All you would need to do is go to services and run a service. I can either run it within a single container by itself, so I don't have to actually run a pod with multiple containers in it. I can just scale out one container at a time, or pods, and I would just pull it from wherever your repository is. So if you've got it up on Docker Hub or one of your own internal Docker repository, who asked the question? Is that you? Yeah. There's also a process if you wanted to have a private repository. There's a process to go through building health checks and things like that. And there's also a submission process where if you wanted to add your framework to the catalog, the public catalog, you could do that. So it really depends on how much effort you want to put into deploying it. Just deploy a container or go all the way up to a public framework.
Nice.
I thought you have a Kibana Elasticsearch. So when I use this solution in your product, do you have integration with FluentD? Everything is here to have a logging solution, or I need to customize?
If you wanted to put together an elk stack, yeah.
But it's done, or I need to do this?
You would need to put them together.
I need to put them together.
Yeah, so
I need to configure my FluentD, everything to.
Yeah, but everything has its own service address within DCOS, so you would just need to point things to their own service addresses. That's, as I was talking about earlier, let's go back to, not this guy, not this, yes, this guy. All these things, these were just base deployments. They were run by deploying a script, but they were just run with the default commands. This is where you basically say, we need to pull the data out of here and put it into that service. That's where you would need to actually build out your services. Sorry, you were late.
I saw you have TensorFlow and the icon of TensorFlow at some point. So how is your support of GPU in terms of resources? Because we looked at DCOS a couple of years ago, and GPU support was not, now it's good. Okay.
We've got, as part of our demo workflow, we've actually got a demo using GPUs on Azure. It's one of the nice things about Azure is they offer GPUs as a workload type, and we can take advantage of that.
Is it easy to upgrade the DCOS cluster?
When you say upgrade, how do you mean expand the DCOS cluster?
I mean, buy a new version.
Sure, if you know what you're doing. It's dual. You can do it. You just have to go through the process of individually upgrading each individual node. That's a place where we can use some help. Is the upgrade process.
How do you compare the installation process between Kubernetes and DCOS?
Can't really. I don't know that you could actually compare the two because the install of Kubernetes is one click on DCOS. On the installation process for DCOS is really lay down your base Linux platform, run the prereqs, which are available through a single script, single executable script. And then it's about 5 command lines to deploy DCOS on each node. You basically have to build a Docker container, which is run within what's known as the bootstrap node. The master then pulls its version. The worker nodes each then go pull their own. So I would actually, if I had to answer the question, I would say it's a lot easier. Granted, I've done it many times, so it's very easy to me. We also do have cloud scripts for deploying it in Azure, AWS, and Google, as well as Terraform scripts as well.
So Archie mentioned it earlier at the beginning of the presentation that Kubernetes and Helm is getting like standardized, or and we have a lot of real estate in Helm. Is there any plan? How does that Helm installation chart application deployment fit with the current roadmap of DCS?
You couldn't deploy it within. Dashboard is one. Here's the dashboard running in.
It's like everything they have is like pure. It's upstream Kubernetes, right? So everything is working in Kubernetes is going to work there. Or maybe meaning they have something similar.
Because he had shown a dashboard where you press a button and get GitLab installed, right?
But this GitLab is going to be installed on DCOS, not on Kubernetes.
Correct, and that's the thing. Well, that's where you need to determine where do you want to deploy it. Do you want to deploy Git and Jenkins on Kubernetes, or do you want to deploy it on DCOS?
Yeah, because like I guess the point here is what you're going to do with big data workloads with the stateful applications, which are getting better with Kubernetes. I know like there are some people like running, like it's not everybody, right? Right now, most of the things running is stateless. Of course, there are like the stateful sets getting better right now. We have a lot of support right now, but I think if you're really running production workload, most of the people trying to use Google or Amazon or Azure services, managed services, right? Like, I'm not going to run MySQL on Kubernetes. I'm probably going to use managed MySQL something. But they also have similar solution that you can run on the DCOS, which is like they've been running those stateful applications for a while and big data workloads as well. So it's a good alternative to the cloud provider.
So if I reformulate, DCOS is the installation of like general framework and infrastructure that are like not Kubernetes, installing Kubernetes itself and the non-Kubernetes friendly app. But if I have my own app on Kubernetes, then yes, I'll use DCS to build my Kubernetes, but then I'll do whatever workflow for deploying my app, and I don't have to go through DCS to.
Right, so here we've got our connected car app. We're actually running minute by minute. We're running deployments of that stuff in Jenkins, and it's doing the deploy. And so the Jenkins is living on DCOS, taking advantage of the framework capabilities to spawn worker nodes and things like that for builds. So if we wanted to do like 20 builds in parallel, it would automatically spawn 20 build processes and allocate resources as desired in Kubernetes. Or
and if you use multiple cloud vendors, because I saw you were using AWS as an example, is there control or logic that could allow us to determine certain rule, and what's the extent to such?
Yep. So remember, Sylvain was talking earlier about availability zones and regions and things like that. So there's different layers of separation. We can do regions, we can do availability zones, or we could just do individual racks. We also have the ability, this is part of the pay-for version, so don't burn me at the stake, the ability to link clusters together, kind of like Windows domain trusts, if you remember those things, so that the different domains will trust each other, the different clusters will trust each other. If I want to have a dev, a test, and a prod cluster.
Any integration with Kubernetes Federation, is there, or that's completely?
When you say Kubernetes Federation, what do you mean?
There's been, and I don't know what's the state of this project, if it's dead or not, but there's been talk before about having Kubernetes, multiple Kubernetes clusters deployed in different data center and somehow act as a whole.
Kubernetes. So right now we have a limit of one Kubernetes cluster per DCOS cluster. The only reason we don't have multiple is that's a feature that didn't make it into the release. That is something that we are actively working on. You can't call it as a service unless you can really deploy multiple. So that's something to be on the lookout for, is multiple Kubernetes clusters on one DCOS cluster. Perfect for development and QA when they need to spin stuff up really quickly.
Yeah. Do you support the airbag rules and network policies?
Oh, RBAC. That's one of the fun things about enterprise DCOS is, you said RBAC, right? Yeah. Okay. Just wanted to make sure. No, I'm going to go back. I'm going to discard. Let's go cancel. And let's go down and look at my organization. So within my organization, I have different users and groups. I can put people in administrative groups. I can put people in user groups. Let's go ahead and let's log out and log in as Caesar. CA dot. What's his password? Hopefully it's his username. So we've just logged in. If you notice, half the screen went away. Why? Because he doesn't have permissions to see any of that other stuff that you may not want him to see. So you could lock things down by application team, by group. Is there anything in particular you were thinking? LDAP integration, of course, as well as some of the new third-party providers as well.
And network policies for the traffic between containers, for instance?
We enable full encryption between containers or between individual nodes. We can do IP per container if you like. Is there anything in particular you are specifically looking for? Okay. Yeah, there's different things we can do based on what you're looking for. Whether it's, that's one of the things, there's two different types of nodes. There's public nodes and private nodes. Private nodes are the workhorse nodes that typically live within your world. Then we have public nodes, which are designed to be put in your DMZ or in places that are publicly accessible. So they will route your traffic so you can give outside world access to those guys, and they will route the incoming calls. That's where you would deploy things like our Edge LB or Marathon Load Balancer or traffic or things like that for delivery deployments, things like that.
Is it going to be any support for new SQL databases? Not NoSQL, new SQL, like maybe
Do they run in a container?
for the framework. I see that you're supporting, let's say, MongoDB and Cassandra, but I did see minuscule databases.
Can you give me an example of one?
Minuscule.
Cockroach, yes. Cockroach, actually, Cockroach is the basis for some of our state maintenance within DCOS. Let me log back in as somebody who can actually, oh, wait, no, they can't get the catalog. The other nice thing is you can actually provide a private catalog that you build internally for your organization. But Cockroach, CO. Cockroach, what was the other one?
Oh, right there. Yeah, right there.
NoSQL. Yep.
Yeah, I didn't see it. Do you guys have, what is, let's say if you're using catalog, how you can build your own manifest to deploy your own solution or?
So I don't have, I don't know how to do that. But if you wanted to just go ahead and deploy a new container, just create a new service. Okay. What do I want to call it? The networking things behind it. Do I want to give it privilege mode so that it can write to the file system? What are the health checks that I want to do on it so that we can determine if it's alive or not? IP per container, what are the...
those workloads in the catalog, are they run as containers or it's different type of workloads?
I guess
the catalog things, they can be deployed in Mesos, not in Mar-13, in Mesos, I guess, right?
Yes, they are Mesos frameworks, correct.
Mesos frameworks, okay, that's what they call it. It's not VMs, it's not containers, it's frameworks.
And most everything runs as containers. It's whether or not you have a framework acting as the watchdog over it. If you saw when we fired up Kubernetes, the first thing it fired up was the framework process for Kubernetes as the watchdog to make sure that everything was running properly and scale out, scale in.
Just to ask, is anybody here using Mesos? Because I remember the first Kubernetes we had like a lot of users. Yeah, really, and everybody wants to run Kubernetes, but it was 2 years ago, less than 2 years ago.
Yeah, that was before
we have a huge community here for being there and AI companies as well, like very popular. So like Kubernetes, of course, is solving part of the issue for them, but like other stuff.
And that's really, we realized that our job isn't to be a container scheduler for stateless apps, for stateless services. That's become a commodity with Kubernetes. It's when Google gave it away, it became futile to try and prevent movement of that. But every single time tonight, we've had a conversation about, what about state? The room went silent. Because that's still something that they haven't figured out yet. They're getting better at it. But we will always be ahead of it.
I think the big data is still very far to be solved in Kubernetes. Like definitely, there's a SIG working on it, but like I think big data is a big still like question mark on Kubernetes. Like it's getting better, but still not there.
Yeah, it's in, and what you want to be able to do is to aggregate your resources, whether they're stateless containers or data services, big data, what have you. You want to be able to take a massive machines and say, allocate those resources to whatever I may want to, whether it's build processes, what have you. Is there a question in the back?
Just the fact that you support new SQL databases, that is kind of stateful application, because you support distributed transactions in a sense, a new SQL database. So that is covered at least for the database aspect.
If you want to play around with it, what's the recommended easiest step to do to
t-shirts left. Oh shoot, because we already answered that question. I was wondering if somebody from
bigger box.
Sorry?
Bigger box?
Well, no, that's one of the ways. That's if you want to just deploy it on your laptop. I'm trying to get to that slide really quickly. Go here, pull down the Vagrant build. There's 3 specific builds. There's the cloud builds, which allow you to use Terraform on AWS. It's not AWS. You can quickly and easily deploy it on VMs or physical machines. If you want to play around with it, I'm more than happy to.
And what's the hardware requirement? Like
minimal.
8 gig, like my Mac, I could run
it. So I run. This is a dual core processor. It's everything will be slow, but it will run. You can get a quad core processor for it, and I'd recommend 16 gig of RAM just because you're going to have to fire up the master, one public node and one private node, as well as a bootstrap node. The Vagrant install takes care of all the memory and CPU allocations. Let me ask a quick question to everybody. Would anybody want to get together over a WebEx session and go through this? Is there any interest in saying a week or two from now, let's spend a few hours on the phone and on a video session, and let's poke the bear?
If you have webinar, I can post it to the.
I don't have anything yet. I'm saying if there's any interest,
you can put it.
Yeah, if there's interest, I'd be more than happy to carve out a few hours on my day and say, hey, let's go to town, and go through the entire deployment process. If you'd be interested, if anybody would be interested in taking a look, yeah.
So, if you guys, any questions? We're still gonna stick around. It's just I think we're slowly ramping up. So we're looking forward for Q2 meetups just before the KubeCon, because KubeCon is going to be first week of May. So we'll try to do end of April. So if you have talks, please submit, or if you have any suggestions what you want to learn. Like I don't know yet exactly what's going to be in the Q2, but if you have any preference or you want to learn something, let me know, or let in the Slack channel know, so we can at least help to find good content for you.
I guess we hear a lot about GPU.
Yeah, well, GPU, I mean, it's just scheduling process, right? Like now it's getting better. We can probably talk about it a little bit. In 1.9, they added better support for GPU. But it's part of the scheduling process. Kubernetes will be able to do this now. Let's chat like here. But I think we should ramp up. The guy we're still here having drinks, beer. If you want to talk about it.
Next meetup, sorry?
Next meetup is going to be last week of April, hopefully. We're still trying to figure out. Maybe nuance. We don't know yet. It was very nice. Thanks to nuance. Thank you everybody for the question.
I'll be around. I'm doing the same talk next week in Philly.
Anybody wants to go to the Philly next week? Join. Hey, you have to need my card or anything. You can like show us at the top right.
By the way, I'm new to Kubernetes, but I've been using Kubernetes for a couple of years.
You know, Brian,
I know Brian. I actually went to the first program. Maybe I have those. But again, I haven't been yeah, well, I can discuss it.
I think
well, that I know very well. That's like 50 years. That's a big part of my life. I like to get one thing I know well, that I can
Okay. How many yeah. Question.